Hello everyone. How are you doing today? Compared to last week, this week is a little bit colder. Last week it was 107 degrees. It's like, and seriously, it's so hard. It's so hard to go outside. Question? Yeah. I graded the exam. I'm going to give you toward the end. Yeah, because you have to fill out the reflection. So I'll give you 10 minutes before class ends, and then you'll do the reflection. You get 2 points each time.
Are the grades higher than the last one or no?
Definitely.
Oh.
This time only 2 student failed. Last time there were many failing, but this time only 2 students failed. Overall, I am actually happy with your grades. Many of you did unexpectedly well, which is good. Yeah, probably it's because the materials are less compared to the first exam. So probably had enough time to study. I hope so. And I hope we didn't cheat. Huh? You know, if you earn a grade and it's a good one, you feel so great. Like, trust me, if you don't cheat and really did get a good grade, like an accomplishment, the feeling of accomplishment, like it's remarkable, it's amazing. So yeah, I hope you didn't cheat. And if you even did cheat, I hope in the next one you don't do it. You do it from your studying, so that you can feel the happiness, the joy of getting a good grade. And I always tell you before the exam, right? For to win the exam, so all you have to do is understand those questions and remember till exam. At least till finalizing it, remember. Okay, we are done with chapter 5, section 10.2, and their homework due date is tonight midnight. If you haven't done that last week.
Is it this?
The last one, chapter 5 and 10.2. We are going to start these. So chapter 6 has 7 sections. Our next exam will be based on chapter 6. So my point is to finish this before next Tuesday. Yeah. Only what? Huh? Only one homework, yeah, because I was thinking about, I thought probably we would be finished some of the homework, some of the materials last week, but we didn't. So the homework for these will be next week, Monday. Homework and quizzes. Now let's see how much we can finish by this week, Thursday, and then I'll do the homework dates based on that. Okay? But definitely the exam will be based on this. And if we can finish early, I should add some of the chapter 7. Because once you're done in chapter 6, we have 7, 10, and 11. So we have 4 chapters, but 3 more exams. Chapter 7, chapter 10, chapter 11. So we need to do 4 more chapters, 6, 7, 10, 11. And we have only 3 more exams. So I have to combine few chapters, probably 6 with little bit 7, and then 7 and 10, and then 11, we'll see. But yeah, for now, chapter 6 is relatively easier because all you need to do is factoring. So I think I can finish chapter 6 this week and we can start chapter 7 next week. I hope. Okay, so all we are going to do in chapter 6 is factoring. Factoring. Once we are done with factoring, then we are going to do solving and then real life application. Okay? Question? No? You sure? You are thinking about something.
Okay, like can I factor instead of always have the quadratic formula, or do I have?
You factor whenever it's factorable. And we use quadratic formula only when it's a solved and it's not factorable. Okay, so anytime it says factor, you never use quadratic formula. Quadratic formula is only for solving. So how do you factor? Depending on how many terms we have, we factor differently. But when we factor, there are a few things we need to know. One thing is what's the GCF? Or what's what's the GCF and your multiplication return table. Okay, these are the most two important things for factoring. Now, before you go to factor, let's see what factors mean. So factors for numbers means what numbers multiply to the number. For example, 3. 3 is a prime number. It has only two factors, 1 and 3. So 1 times 3 gives you 3. So 1 and 3, they are the factors of 3. 4 is not a prime, so it has more than two factors. If you multiply 1 and 4, you get 4. If you multiply 2 and 2, you get 4. So factors of 4 are 1, 2, and 4. 16 is even bigger than 4. And we can get 16 three different ways. One is 1 times 16, then 2 times 8, and then 4 times 4. So the factors of 16 is 1, 2, 4, 8, and 16. So factors means if you multiply two things, it's supposed to get what you're factoring. Okay? So anytime you multiply your factors, it's supposed to get what you originally have. So if you break down a piece into two pieces, when you multiply the two pieces, it's supposed to get that back. If you don't get it back, that means these are not factored. You get something wrong somewhere. Okay? So when you factor, you break into smaller pieces. And in order to get back to the original one, you multiply the smaller pieces and you get the original piece back. So factors and multiplying, they are reverse process. Now ignore. Let's do some GCF. GCF means greatest common factor. So observe 16. It has 1, 16, 2, 8, 4, 8. So many factors. For 4, we have 1, 4, and 2. 3 factors. So greatest common factor means from within two numbers, if you have many factors in common, what is the greatest common factor? Okay. For example, 1 you have here, 1 you have here. You have 4 here, you have 4 here. You have 2 here, you have 2 here. So the common factors between 4 and 16 is 1, 4, and 2. 1, 4, and 2, they both, all of these are in 4, and also all of these are in 16. So among 1, 2, and 4, which one is the greatest common factor? 4, the bigger one, the biggest one. Greatest means biggest one. So greatest common factor means which number, by which number you can divide all the numbers you are finding GCF of. For example, we have 12 and 20. So we do it mentally, but let me show you how do we do it without doing them mentally. Like once you're learning it for the first time in your life. So if you're learning it for the first time in your life, all you have to do is factor each one of them. For example, 12. Yeah. Come on. 12 is 1 times 12, right? And then 2 times 6. Anything else? 3 and 4. 3 times 4. So the factors of 12 are 1, 2 is 1, 2, 3, 4, 6, and 12. These are all the numbers by which you can divide 12. You cannot divide 12 by any other numbers. Now look at 20. 20 is 1 times 20. 2 times 10. Anything else? 4 and 5. That means by only these numbers, you can divide 20. You cannot divide 20 by any other numbers. Okay, so these are all the factors of 20, and at the top we have all the factors of 12. Now, greatest common factor means compare what factors we have in common. We definitely have 1, 2, 4, and nothing else, right? So among 1, 2, and 4, which one is the greatest common factor? 4. So GCF of 12 and 20 is 4. We actually do all of these things mentally. Okay, so if you can do it mentally, you're fine. If you cannot do it mentally, make sure you do it this way at the beginning, and then once you get used to the process, you can do it mentally. Any questions so far? So for numbers, we look at factors. For variables, it's a little bit different scenario. So here, y square. When you divide y square, what do you get? When you split y square, what two numbers gives you y square? Definitely y times y, right? In multiplication, we add the powers. So y square means y times y. Look at y to the 4. Y. You're multiplying y 4 times. So 1, 2, 3, 4. You have y to the 4. Now look at y to the 7. We have to multiply y how many times? 7 times. Now, greatest common factor means what do you see in all three polynomials? How many y's do you have in all three polynomials? 2 of them. We have 2 of them here, 2 of them here, 2 of them here. So definitely they all have 2 of them minimum. They all have minimum 2 of them. So GCF here is that minimum 2 of them. So for variable, even though it is greatest common factor, but you actually take the smallest power. For number, we look at the real bigger number, the biggest number we have in all three factors. All common factors. But for variables, we say greatest, but we actually take the smallest power. So among y squared, y4, and y to the 7, 2 is the smallest number. So GCF is the y to the 2, y squared. Okay? In multiplication, we add the powers. So y squared means it's y times y, so you have 2 of them, y. In y to the 4, you have 4 of them. In y to the 7, you have 7 of them. So how many y's you have in all 3 of them common? Maximum 2. They all have maximum 2 in common. So we take that 2. Now it's a combination. What do you do when you have a combination of numbers and variables? You take the GCF of the numbers and then GCF of the variable. It's like you're comparing the factors of 8, 6, 10, and you're also comparing x squared, and x cubed. You're comparing them separately, and then you're putting them together. So let's do it the way we did before. What are the factors for 8? 1 times 8, 2 times 4. Anything else? No. How about 6? 1 times 6, 2 times 3. And how about 10? And 2 times 5. So which number, the biggest number you see in all the factorings in common? 2. So from the numbers, our GCF is 2. Now for variable, x alone means only one axis. X square means you have 2 of them. X cube, it means you have 3 of them. So what is the maximum amount you see in common in all 3? Only one of them. They all definitely have one of them. So our GCF is x for the variable. Who is lost? Don't be afraid. If you didn't understand anything, ask me. If you don't understand the base, then factoring will be hard for you. Really. But if you understand this, the main idea of factoring GCF, then life will be a little bit easier for you. Any question from anyone? No. Okay, then for you guys, let me give you an example. Find the GCF of, let's say, 16x squared, 24x to the 5, and 12x to the 6. What is the GCF of these 3 things? You already done? Give me 1 minute for them to do it. Okay, Eliza, go ahead. 4x squared. Do all of you guys agree with him? Is it 4x squared? Does anybody have anything different? If it's wrong, no problem, let me know. I will help you to correct it. No? Okay, so between among x squared, x to the 5 and x to the 6, we have to take the smallest power, which is x squared. So definitely x squared is correct. Now between 16, 12, and 24, let me show you a trick to do it in faster way. Among 16, 24, and 12, which one is the smallest number? 12. So you only have to find the factors of the 12. What are the factors of the 12? 1, 12, 2, 6, 3, 4. Now, let's start with the 12. It looks like 13. 12. Can you divide 16 by 12? That means 12 definitely cannot be the common factor. How about 6? Can you divide 16 by 6? No. How about 4? Can you divide 16 by 4? Can you divide 24 by 4? So your answer is 4. Okay. So you don't have to write down the factors for every one of them. Just take the smallest number, find its factor, and see starting on the biggest one, like which one you can divide by all three numbers. And that way you can find your DCF easily. Easier than that way. So any question? So that's how we find the DCF of numbers and variables. But what you're going to do now is you're going to find factors for not numbers and variables only, factors for polynomial. And our polynomial may have different terms. So if you have only two terms, there are only two ways you can factor. Either you can factor out a DCF, or you can use the difference of perfect squares. Difference of perfect squares means something like a square minus b square. Okay, you have perfect squares and minus between them, so you can factor. Do you guys remember what are the two factors of difference of perfect squares? Good. It's the sum and difference of their bases. So when you have only two terms, either you can pull out a DCF, or you have to use difference of perfect squares. There are only two methods. If it's factorable. If it's not factorable, we call them prime polynomial. Means it's not factorable at all. Now, when you have four terms, again, you have two choices. Either you choose DCF, or you choose grouping method. So you have four terms, we group them into two groups, and then we take out DCF, and then we pull out another DCF. We call them grouping method. So two terms and four terms, they have only two choices. First one is definitely DCF. If you don't have any DCF, or after you pull out a DCF, maybe you can do more. For two terms, you can use difference of perfect squares. For four terms, it's grouping. And now comes three terms. Three terms is a special case. It has so many ways of factoring. First one, definitely DCF. If you see anything in common in all three terms, you have to pull it out. And then you have first method, direct factoring. In direct factoring, we look for two numbers. So three terms, they have the format ax squared plus bx plus c. Okay. So in direct factoring, we look for two numbers multiply to c, combine to a, combine to b. If your x squared is 1, sorry, if your a is 1, for example, if you have x squared plus bx plus c, then we look for two numbers multiply to c, combine to b. That's it. That's all we have to do. It's called direct factoring. For AC method, if you have ax squared plus bx plus c, a is small letter, okay? Then the AC method is multiply a with the c, and then use find two numbers, multiply to AC, combine to b, and then use the grouping method. So AC method is the grouping method. We rewrite three terms into four terms and then use group. And then the last method is trial and guess. You can use trial and guess for when A is 1 or when A is not 1. You can use trial and guess for any method, it's okay. But trial and error guess method is only helpful if you have multiple choice given to you. Based on the given multiple choice, you can see what two numbers will work out in trial and guess method. Otherwise, there's so many choices to play with. So make sure you have them in your notebook. Our entire chapter 6 is that's it. You're going to factor two terms, three terms, and four terms. And based on what is given, we have these choices. So if you know what to do in given scenario, your life is easy. Question. Okay, let's do some example. How many terms do we have here? One term, two terms. Terms means between any two things, if you have plus or minus, they represent term. So we have 40 plus 12. That means 40 is one term, 12 is another term. So you have two terms in A. How many terms do you have in B? Again, two. So we have one term here, another term here. So we have two terms. So for two terms, either DCF or difference of perfect squares, and or, okay? Sometimes you have to use both of them. Sometimes only one of them. So for the first one, what do you observe? We have 40 plus 12. Is it DCF or perfect squares? Remember, perfect squares, difference of perfect square, we have to format this way. Something square minus something square. Do you have that in A? No. It's definitely not difference of perfect squares. That means it could be DCF. Now, we have t in the first term, we have no t in the second term, so definitely our variable doesn't have any DCF, right? Because only one term has a variable, the other term doesn't have this variable. So we are only looking at 4 and 12. Between 4 and 12, what's the DCF? 4. So you pull out a 4 and then you rewrite the remaining things. So when you factor out something, it means whatever remains is their quotient. If you divide the term by whatever you're factoring. What does that mean? If 40, if factored out 4, it means you're dividing by 4. So what is 40 divided by 4? Only t. So the first term turns into only one t instead of 4 because it pulls out the 4. And then here plus. We have 12, we factored out 4, means we are dividing by 4. 4 goes to 12 how many times? 3. So our second term turns into 3 instead of 12. And that's it, we are done. That's how we factor out a DCF. We observe both terms and see for numbers by which we can divide both of them. And for variables, what is the smallest power? Any question? Next one. X plus 2y. The first one has variable x, second one has variable y. So between variables, do you see anything in common? Yeah, but variable is x and y, so variable doesn't have anything in common. The first one doesn't have any number, second one has 2. So you have two choices. Either you can pull out a 1 and you can write x plus 2y. We are going to do that when you do grouping method. Okay. We'll do this in the, you know what, let me write nicely. We will do this in the grouping method. But since here we are not doing the grouping method, so you can simply say it's a prime polynomial. It's a prime polynomial because we cannot factor out anything else besides 1. So in the grouping method, we cannot use prime word. We have to pull out 1. But if you have only 2 terms or 3 terms, you can say it's prime because we don't need 1 to pull out. Clear? Think about this one. y to the 8 plus y to the 4. The variable scenario. Great. And then what remains? So it's definitely y to the 4 because 4 is the smallest power. For variable, you always pull out the smallest power. So y to the 4 is our GCF. And now you have to write what remains. Here y to the 8. Factoring out means what? Dividing. And in division, what do you do with the powers? Subtract. So what is y to the 8 minus, what is y to the 8 over y to the 4? Y to the 8 minus 4, which is y to the 4. What about the second term? It becomes what? Great 1. Here y to the 4 and you factor out y to the 4. They cancel out because they're the same thing. Or you can write y to the 4 minus 4, which is y to the 0, which is 1. You don't have to do that, but whenever you're the same thing, it turns into 1. No, these are mental things. So we do all of these mentally, but I'm showing you because you're learning it. Many of you are learning it for the first time. So I want to show you the mechanism behind the mental work we do. Once you get used to it, this, you're going to do this.
Where the one is there right one? Or we just have to
No, y is a variable. It's not 1. You can write y if it was y to the 5. If it was y to the 5, you factor out y to the 4. So 5 minus 4 is 1y. So y cannot be the answer. Okay, the next one. 3 terms, and 3 terms has 4 choices. GCF, direct factoring, SE method, trial and guess. So this is term number 1, 2, and 3. We had a combination of numbers and variables. For variables, what's the GCF? So definitely a cube, because this is the smallest one. And for numbers, you have 12, 12, 4. So what's the GCF? Definitely 4. And now let's think about real life. Would you like to start your day with something negative in your life? Definitely not, right? If you start your day with something negative, the whole day will be something, you're going to face something negative. So you don't want to face something negative when we wake up in the morning, the first thing we see, right? Same thing for the polynomial. If your polynomial starts with a negative, we don't like it. So even though we don't have negative in all 3 terms, but we have to factor it out because we don't like our polynomial to start with a negative sign. So factoring out negative means all the sign will change. This will turn into positive, this will negative, and this is positive. Okay. Now we have 12 a to the 5. We factored out 4 a cube. What remains? 4 goes to 12 3 times. And we have a to the 5 divided by a cube, a square. It was negative, but we pulled out a negative, so it turns into positive 3a squared. So if you want to see the work, we have negative 12 to the 5. We factored out negative 4 a cube. Negative, negative cancel out. 4 goes to 12 3 times. And from here, we have a to the 5 minus 3, which is a squared. So positive 3a squared. We did all of these mentally. How about the next term? The plus 12a to the 4 turns into what? It's not plus anymore, right? It's minus 3a. Good. The plus turns into minus because we factored out, which we are dividing. Okay, let me do it. We have plus 12 a to the 4, and we are dividing by 4a cubed. Plus and minus turns into minus. 4 goes to 12 3 times. In division, we subtract the power. So we have a to the 4 minus 3, which is negative 3 a to the 1. But 1 is invisible. So we get negative 3 there. And how about the last term? Good. Last one. So we have negative 4 a cube, and we factor the exact same thing out. So all of this cancel out. We have 1 with a plus sign. We're doing out with here dividing. So when you have the same sign, they cancel out. We have 4 divided by 2 divided by 4. It's 3. In division, we are using the power. That's going close. In division, is subtract the power, so it's square. Any question from anyone? So these are the main base of all the factoring. How to use GCF. Once you're comfortable with GCF, then we go to the next harder stuff. For example, how many terms we have now? 4 of them. And for 4 of them, what are the methods we have? The first one is always GCF. And for the second one is grouping. So this one is either GCF 1, and the 2 is grouping. So let's look at GCF first. Do you see anything in common in all 4 terms? For the numbers, we have 4, 8, 5, 10. Definitely 5 is not divisible by any of the other numbers, right? So we don't have anything in common. And then the first one is x squared. The second one is x. The third one is x. But the last one doesn't have any x. So x is not a GCF here. Same thing, we don't see y in all 4 terms. So y is also not a GCF. So 4 terms individually, they don't have any GCF. So the GCF doesn't work. So you go to the grouping method. In grouping methods, we take 2 things. Take 2 terms, make them into one group, and then take another 2 terms, make them into another group. So instead of having 4 terms, we have 2 groups. Each group has 2 terms. And now we are doing GCF individually in each group. So in the first group, now do you have any GCF? We have 4x squared and 8xy. Between 4 and 8, do you have any GCF? 4. And now between x squared and xy, only x's. So when you compare all 4, they did not have a GCF, but when you group them, now they have a GCF in the first group. So what remains in the first group? The 4x squared turns into what? only x, and the 8xy minus 2y. And if you multiply them, you're supposed to get 4x squared minus 8xy. You can check or multiply. Any question on the first group? Now the second group, what do you observe the second group start with? Not positive 5, right? Negative. Do you like to start something with negativity? So anytime you see something starts with negative, always factor that negative out. And now observe 5x and 10y. Between variable, we have x and y. Do they have anything in common? No, they're two different variables. That means the only hope we have is the numbers 5 and 10. What is the GCF between 5 and 10? 5. So let me actually change color. No, not, yeah. We have 4x and only 5 here. So we are factoring not 5, but negative 5 out. So what is left in the first term, the second group? Only x. What? Positive or negative? Negative. We have plus 10y, and you're dividing by minus 5. So plus 10y divided by minus 5. The sign turns into minus. 5 goes to 10 twice, and we have our 2. We have our y. We still have our two groups. This is what we got in the first group. This is what we got in the second group. No, because we did not touch the first group once we are done with that. So whatever you factor out, it only affects that group, not the other group. Maria. Yeah, so in both groups, the power doesn't matter if you don't have the same variable. So if you have x squared and y, it still doesn't matter because x and y, they don't have anything in common. But if you have x and xy, then they have common x. Now look at two groups together. What do you observe in both groups? X minus 2y. They both have this individual in them. So it's time to take that out. X minus 2y. So then what is left in the first group? 4x, and the second group minus 5. And now we are finally done. So we are doing DCF, but not all together. We are doing it piece by piece. So we're doing it 3 times. One time in the first group, one time in the second group, and then the third time in the second line, comparing both groups. And that's what we're going to do AC method. In AC method, we're going to turn 3 terms into 4 terms and then do the exact same thing. Okay? Any question? So in your exam, yes, you have 2 terms, 3 terms, 4 terms, all the terms you have in your exam. So go ahead, try that. And if you don't have the exact same thing, it cannot move any further. You have to stop here if you don't have the same thing. Brendan, not here. Liliana. Martin here. Christopher, not here. Axel, Matthews here. Eliza here. Angel here. Honda here. Maria here. Ashley here. Exona here. Jason here. Kathy here. Asim here. Kayla. Oh, you change your seat here. Krishel. Helicius. Mariam here. Hey here. Chanel here. Jasim here. Jonathan here. Hey, are you guys ready? Miliana, what do you have in the first group?
In the first group, we have 2.
And then what remains?
X minus 1.
Perfect.
And then plus 2x squared minus 1.
Minus 1. Okay. What do you observe now in both groups?
Both have x.
So you factor out x minus 1. X squared. Are we done?
No, also.
What did you do?
I did it the cheese syrup.
Good. Observe this. 2, 2, 2, 2, 2. What do they all have? Definitely 2. So you have to pull out a GCF. Either you do it at the beginning or observe here. In the second factor, we have 2 in both terms. So we have to factor out GCF now. So you can factor at the beginning or you have to factor at the end, but you must factor out a GCF anytime you have a GCF. So from here, it's not complete yet. You have to factor out the 2. So what remains?
1
plus
x squared.
X squared. Now, if you observe all 3, we have a 2, which is a GCF. Then we have x minus 1. And then we have our second polynomial, 1 minus x squared. So 2 choices. Pull out the GCF first or pull out the GCF at the end. But you have to pull out the GCF. Eliza. Even from here to here?
No, that second one's second.
From this line to this line?
The one in, like, from that to the.
From this line to this line.
Yes.
So we have x minus 1, which doesn't have any GCF. We have this, but it has GCF. So this turns into 2 terms, GCF and whatever it is. So we have 1 term, 2 term, 3 term. So you have to combine this because this is already done once you factor it out. So we have 2 GCF from here, x minus 1, and once you pull out the GCF, we have 1 and x squared. So this is plus, not minus. 1 plus x squared, my bad. 1 plus x squared. So we have this and this. These are the final factors of what we have. But see, it's kind of confusing, right? So anytime you see a GCF, pull out a GCF first. So let me show you. It doesn't make any difference. At the end, you're supposed to get the same answer. But if you get confused, or you have 2x minus 2 plus 2x cubed minus 2x squared. You have 2, 2, 2, 2. Factor out the 2. You have x minus 1 plus x cubed minus x squared. And then you do the grouping method. So we have 2, we bring it down. In the first group, do you have anything in common between x and 1? Nothing. So when you have nothing in common, what do you have? 1. So we write x minus 1, but we just put a 1 in the front. In the second group, we have x squared, so we have x minus 1. And all of them, they have 2 in the front. Now we have x minus 1, x minus 1. So we bring our GCF down, and from the 2 factors, we have x minus 1. So we factor out, and we have 1 here, and plus x squared here. So 1 plus x squared. You have the exact same thing as this one. But it's better to always plot the GCF at the beginning. Not when it's a smaller number, it doesn't make a difference, but when it's a big number, it does make a difference. One more question. By same as this one, the only difference is what? The last one had a GCF 2, but this one doesn't have a GCF 2, so you cannot plot it 2 at the beginning. You have to go to grouping directly. So Katie, in the first group, what do you observe? 2. When you factor out, what remains? Okay, it's minus 1. In the second group, what do you observe? Only x to the second. When you factor out, what remains?
X minus 1.
X minus 1. You have x cubed, you factor out x squared. So 3 minus 2 gives you x to the 1 power. In the second one, we have x squared, and you're dividing by x squared. You have 1 left. Now, still in both groups, what do you have? So it's same as this one. The only difference is this has a GCF2, this one doesn't have a GCF2. Any question? Okay, so we did 2 terms, we did 4 terms, and now it's 3 terms. 3 terms has 4 choices. GCF, direct factoring, AC, trial. And we are going to learn all 4. We already know GCF. We already GCF few times. Let's go to the direct factoring. In direct factoring, in order to do the direct factoring, our rule says A has to be 1. So instead of ax squared, we have only 1x squared at the beginning. So if you have only 1x squared and then something x, something number, the direct factoring method says find 2 numbers, multiply to the constant, and when you add or subtract, so combine, when you combine them, it has to give you the beta, the middle coefficient. Once you figure them out, all you have to do is write them into 2 binomial factors, and then you write x squared into x and x, and then those 2 factors. So this x, so we have 2 factors. Our goal is to rewrite 3 terms into 2 factors. So split x squared into 2 pieces, x and x, and we split c into 2 pieces. Now c is a number, so it could be anything. Depending on the number, we factor the c. We see which 2 factors multiply to c, but when you combine, it turns into the middle term. This term. We put them next to the x's, and that's it. We do this factor in one line. Okay, we don't have to do any math. We just, from the given equation, we just go binomials. That's it. The note says, check your work by multiplying the 2 factors back out using FOIL. So if you want to check whether the factors are correct or not, all you need to do is use FOIL and then see if you get the same polynomial back. If you don't, that means something is wrong. If you cannot factor, we call them prime, and a polynomial is completely factored when it's written in the product of prime polynomials. So the 2 polynomials, the 2 factors we got them, they cannot be factored anymore. For example, here, we could not stop here because this is more factorable. So until it's not factorable anymore, you have to keep factoring again and again and again and again. Okay, that's the rule. Factor completely means at the end result, they cannot be factored anymore. Okay. Now let's see that. The first one, how many terms we have? X squared minus 4x. 2 terms. So are you going to use direct factoring? No, we don't have to. Because it's only 2 terms. So what do we have in 2 terms? What are the 2 possibilities? GCF or perfect square? What do you observe? But what do you observe in the first glance? Perfect square or GCF? GCF always has to come first. Always. Do you see any GCF between x squared and 4x? X. So you have to factor out your GCF. Now, when you factor a GCF out, do you still have a perfect square? Your x squared turns into what? X. And your minus 4x turns into what? Minus 4. What do you observe here? Are they still difference of perfect squares? No. So you stop here. Even though at the first place it looks like we have difference of perfect squares, but actually we don't. We have GCF. And GCF always comes first, always. Now compared to that, let me give you another one. Observe this one. What if you have x cubed minus 4x? What do you observe now? In x cubed minus 4x, what do you observe first? GCF. What is your GCF? Definitely x, right? So you have x squared minus 4. And now observe here. What do you observe? Perfect squares. Right, just smaller. So this is x squared minus 2 squared. Our two bases are x and 2. So when you factor, it becomes x plus 2, x minus 2. So yes, in some example, once you're done with GCF, you're done. We cannot go any further. But in some example, once you follow the GCF, you still have to factor more because we have more choices are given. So two terms, GCF or perfect square. Definitely one of them. If it's not, then it's prime. Means it's cannot factorable, it's not factorable. Okay, so in the exam, expect to see this. Exam. I'm going to give you something where you're going to GCF, apply GCF and perfect square. And now the third term. Our x squared doesn't have any number in the front. So we want to see whether it's factorable or not. If it's factorable, then we can factor them directly this way. We divide x squared into x and x. So this x squared turns into x and x. Now for 5, what are the factors of 5? 1 and 5, right? But we want negative 5. So negative 5 times 1 is negative 5. And negative 5 plus 1, negative 4, the middle term. So when you add or subtract, the combination has to give you the second term. When you multiply, the product has to be the third term. So multiply to C, combine to B. That's your rule for direct factoring. It cannot be negative 1, positive 5, because negative 1 plus 5 gives you plus 4. In the middle term, we have minus 4, not plus 4. So this doesn't make sense. We have to have plus 1 and minus 5. And that's it, you're done. For the first one, it may seem confusing, but we are going to do a lot in this class. So you will be fine. Come on. How many terms do we have? 3, right? 1, 2, 3. And our x squared doesn't have any number in the front. So it's direct factoring. We rewrite x squared as x and x. And now, oh, let me show you another thing. The two factors we are going to find, one of them has to have a negative sign because our middle sign is negative. And which one? The bigger one. The two factors we are going to get for 10, the bigger one has to have negative sign. Now, which two numbers multiply to 10, and when we add or subtract, you get 3. 5 and 2. So the 10 turns into 5 and 2. So if you're confused about sign, remember, one of them has to be negative. Which one? The bigger one. So we know 10 is 1 times 10. But when you add them, either they're going to give you 11 or 9. So we cannot have it. And then we have 2 and 5. For 2 and 5, you're going to get either 7 or 3. If you add them, you get 7. If you subtract them, you get 3, right? And we have 3, so definitely this pair. Now between 2 and 5, 5 is bigger, so it has to be a minus sign because we are given a minus sign. Now if 5 is minus, what sign 2 has to have in order to get 3? Positive. That's why 2 is positive, 5 is negative. Who is lost? Anybody? Let's do a few more. Ready? Now, which two numbers multiply to 27 combined to -6? 27. Definitely it's 1 times 27. Right? But if you add them, we get 28. If you subtract them, we get 26. This doesn't work. What else do you have that multiply to 27? Can you divide 27 by 2? No, because 27 is odd. How about 3? Can you think of 3 times something 27? 3 and 9. Now if you add them, you get 12. If you subtract them, you get 6. And you're looking for 6. So definitely it's 3 and 9. So one of them is 3 and one of them is 9. And what is our variable? R, not X. Now what sign 9 has to have? Negative, because it's given. That means from -9, if you want to get -6, 3 has to have what sign? Plus or minus? -9 minus 3 is what? And -9 plus 3 is what? What is -9 minus 3? -12. And what is -9 plus 3? -6. So what sign 3 has to have? Done. The next one. Which numbers multiply to 54 combined to 15?
X plus 7, X plus 8.
7 times 8 is 56. Sorry. Yeah, 56. 9 and 6. X plus 9, X plus 6. 6 times 9 is 54. So the second important thing I told you about before is timetable. If you don't know a timetable well, you're screwed. So make sure you review, all of you, review your timetable very well from 1 to 12. That's all you need to know, 1 to 12, your timetable. Okay, 3 more. Go ahead, try them. And do I have more? Oh, one more. Do I have more? No. Maybe I can put the last one here. To the 4 minus 5 squared minus 14. Okay, 4 more. And then you will be done with direct factoring. You may think F and G are same, but definitely they are not same. They look same, but they're not. Who is done with F? The first one. X plus 3 and X plus 2. Almost correct. But remember, when you add them, you're supposed to get the middle sign. So plus 3 plus 2 will give you plus 5. But what do you given? So minus 3 minus 2 give you minus 5. And when you multiply negative 3, negative 2 will give you plus 6, which is the third term. So it's not actually plus, it's minus. So you have to be careful about sign also. But good job.
What about 6 times
1? Okay, so 6 times 1 is 6. 6 minus 1 is 5. So you have to observe the sign, right? So what is your sign for the 6 and 1? It's negative sign, right? So 6 definitely has to be negative. That means 1 has to have what sign? Plus or minus? Plus. So you get -5, right? But when you multiply, what do you get? What is -6 times 1? But what do you have? So does it work? No. But how about the next one? Multiply to -6 combined to -5. -3 times 2 gives you -6, correct? But -3 plus 2 is how much? -3 plus 2 is -1, not -5. If you think both has to be negative, then -3 minus 2, -3 minus 2 is +6, but you are given -6. Oh, no. The second one. So in the exam, be very careful. You have to check your sign also, not just the number, the sign. The second one is actually -6, +1. Because -6 times 1 is -6, -6 plus 1 is -5, which we have in both cases. So this is wrong. So that's why these two are the trickiest numbers, trickiest polynomials. And in the exam, expect to see this. F and G. They look same. Their factors are almost same, but not everything works. Who would like to do the third one? That's why. Martin? X minus 1 and x plus 9. Almost correct. So if you multiply x times x, you will get x squared, right? But if you multiply -1 times 9, do you get -9y squared? So you have to have a y here. Remember that the second term multiplied with the constant, third one, and the first term multiplied with x squared. So you can ignore the y square for now, and you can think of two numbers multiplied to -9 combined to +8. Definitely it's 9 times 1. 9 has to be positive because our sign is in the middle positive. That means 1 has to be negative. But then the third term not only have numbers, but it also has variable. So it is split in y squared into y and y, just like x squared. Question? Eliza?
So you added some. Where would you get that? I get the y squared.
The 8xy comes from the foiling. When you FOIL, you have x times x squared. X times 9y is 9xy. X times -1y is -1xy. So plus 9xy minus 1xy gives you 8xy. And then 1 times -1 times 9y. So you can always check your one by multiplying them back. Okay, so what do you have as your answer?
Can I ask you? Well, like instead of like solving one, I just have to like in like staying with one, you know, the normal. Instead of like the x output one, be like y.
So you have y squared minus 5y minus 14.
Right, and then you factor over. And then towards the end you add to like x squared.
So you let your y to be x squared.
Yeah. And then not -7 plus 2.
-7 plus 2. So here we have y minus 7, y plus 2. But your y is x squared. X squared minus 7 and x squared plus 2. Or you can simply think of this as split y to the 4 into 2 pieces. Y squared, evenly. And then you just do the multiplication. Two numbers multiplied to 14 combined to -5. Definitely 7 times 2. 7 has to be minus because the middle side is minus. So from 7, if you want to get 5, you 2 has to have the opposite sign. So 2 is plus. So this black method is called U substitution, which I usually don't use. I straight go to the factoring by splitting x to the 4 into x squared and x squared. That's all you have to do. Your substitution is always better than that one because you can see what's going on. But that one, let's say you don't have time. You have only 1 second or 2 seconds during your exam. So doing substitution takes time. So you can simply divide the x to the 4 into 2 pieces. That's it. X squared and x squared. Always divide anything into even numbers. Let's see, x squared is x and x. So you divide them evenly. Same thing, x to the 4 to divide evenly. X squared and x squared. Okay, with this, we're done with direct substitution. And now we are going to do 3 terms where we are going to apply GCF. So just because you have 3 terms, it doesn't mean you can factor directly. Sometimes you just do GCF and then you're done. So look at this one. -2x squared y, 30xy, 34y. If you look at the variable, this has x, but this one doesn't have any x. So can you pull out x as a common factor? This one has y, this one has y, this one has y. Can you pull out y as a common factor? We have y here, y here, y here. So they all have y in them. Y keeps moving. So we have y, y, y. So definitely we can pull out, we can pull out a y. But we cannot pull out any x's. Now look at the numbers. What do you observe? Your polynomial starting with what? Do you like negativity? So you have to pull out a negative. Something is wrong. Okay, it's wrong. I'm very sensitive today. Okay, I want to do this one. My left side is very sensitive. We have to have a number in picture. So we definitely pull out a negative. We can pull out a y. Now look at the numbers. 2, 30, 34. Can you factor out any number? 2. So GCF is -2y. Now let's see what remains. What is left in the first term? -3 and y is gone, so only that square. And then we have -30xy. We are dividing by -2y. If you want to see the work, we have -30xy and you factor out negative 2y. Positive 15x. And then we have 34y. What remains? Positive or negative?
No.
Negative 17. So we have 34y, and we are dividing by negative 2y. Y cancel out. 2 goes to 34, 17 times, so negative 17. Can you factor 17? Can you find two numbers multiple to 17 combined to 15? 17 is prime. The only two numbers it has as factor is 1 and 17. Bless you. If you add them, you get 18. If you subtract that, you get 16. But what do you want to have? So is it factorable? So you're done. So this is an example where DCF is the only thing we can do. But in an exam, you are going to have DCF and more factoring. So I'm going to give you something when you pull out the DCF, you can factor more. Okay. Let's do the next one. Next one looks scary, right? Fraction. You cannot, because it's not equals to some number. If it's equals to some number, then we can get you the denominator. But it's a polynomial. It's not equal to anything. So we have to work with fraction. From the variable, can you pull out anything, any variable? First start with variable. We have y squared, the first one, second one is y, third one doesn't have any y. So can you factor out any variable? 1/2 is not variable, 1/2 is number. So for variable, we cannot pull out anything. Now observe the numbers. You have 1/2 and 7/2. We can always factor out the smaller one. Which one is smaller, 1/2 or 7/2? 1/2. So we can actually factor out 1/2. So we have 1/2 y squared, and we factor out 1/2. What remains? 1/2, 1/2 cancel out. We have y squared. Now observe the second one. We have negative 7/2 y, and we factored out 1/2. What do you think we should do? But how? How? Why? Dividing by a fraction is not possible. So instead we multiply by what? The reciprocal. So we keep our negative 7/2 y. And instead of dividing by half, it's times by 2 over 1. We have 2 on the top, 2 on the bottom. They cancel out. So what remains? Negative 7y. So even though it's a fraction, but actually it's still factorable and simplificable. And now the last thing we have, negative 22, we are dividing by half. Ha ha ha, wrong. Good job. Dividing by half means what? Multiplying by reciprocal. So it's not 11, it's 44. Negative, because 22 is negative. Can you factor more? Multiply to 44, combine to 7. So what factors we have? 11 and 4. 11 has to be what? Negative. And then 4 has to be positive. So see, I'm going to give you an example, something like this, not with a fraction, but something that is factorable with GCF. So this is more factorable. So we have what GCF 1/2, and this turn into x minus 11 and x plus 4. What? I didn't hear it. What did you say? This one? No. Exactly. That's why you pulled out a negative. Look at this polynomial. What does it start with? Positive or negative? So this is what you want.
Oh, so it doesn't matter about the thing outside.
Because GCF.
Okay.
You factored out GCF and you want something nice inside. And this is not factorable, but that nice thing is more factorable. Say factor more.
So that's so negative.
If it has 16, we could have factored. But if it has 15.
Well, say it was negative x squared, if you switch it and make it negative 2y, and you switch everything, like positive x squared. Like say it was positive 2y from negative x squared, which you
have to pull out the negative.
Okay.
So all the sign will change. The main idea, the main thing is, whatever you're factoring, that the remaining, you don't want that to start with negative. You can, but you want that. Just like you can wear your clothes upside down or inside out, but we don't, right? Because it's not normal. So you can, but it's not normal. Okay, we are done with 6.1, 6.2. So definitely have your homework and quizzes on 6.1, 6.2 next week, Monday. And now we are starting 6.3. My class is over, so I'll stay here, okay? So no more early leaving. I'm done with my class. Okay, 6.3, we are factoring. What's wrong? We are factoring using trial and guess. Trial and guess actually is a fun method. And we are going to use trial and guess in this class only when multiple choice are given. So in your final exam, you'll definitely have one of these. What's wrong with this today? One of these where you have your A term and C terms are big numbers. So all these examples we did, they are smaller number, 1 for x squared, and for constant it was small numbers. But now we have big numbers, 14, 15, 29. All of these are bigger numbers. And they gave us the choices. They're asking, when you factor this polynomial, this quadratic equation, one of the factor has to be from these three. Which one? So for trial and guess, what we do is, we split the leading coefficient and we split the constant. And then we see which combination gives us the middle term. So 14. Definitely 14 is 1p and 14p, right? 1 times 14 is 14p times p is p squared. Or it's 2p and 7p, right? 2 times 7 is 14 and p times p is p squared. Now, which of them we're going to use? We go to the multiple choice and see what multiple choice have. In the multiple choice, the first term is either 2, sorry, all of these are p, okay? P. So the multiple choice, we have 2p, 7p, 7p. So what do you think is the best option to work with? 1 and 14 or 2 and 7? 2 and 7. So see, we're not going to work with this. Because the multiple choice don't have 1 and 14. They have 2 and 7. And now we're going to do the same thing for 15. 15 is definitely 1 and 15. And what else? 3 and 5. Now let's go to the multiple choice. We have 5, 3, and 5. So which pair we think is supposed to work with? They also have 3 on the negative. But both of them cannot be negative because our product is negative 15. So we are going to worry about negative sign later. Let's worry about just the number. Which pair you are going to work with? 115 or 35? 35, because multiple choice has these two. So our life becomes easier. Now all you have to do is play with them. We are going to take one from the left, one from the right, multiply them, and see which combination gives us positive 29. So let's see this pair. What is 7p times 3? 21p. And what is 2p times 5? 10p. If you add them or subtract them, do you get 29p? No. So my pairing is wrong. I have to erase all of these because they didn't work out and pair the other way around. 7 goes with 5 and 2 goes with 3. Now let's see what do we have this time. What is 2p times 3? 6p. What is 7p times 5? 35p. And when you add or subtract, is there any way we get 29p? Is it possible? Yes. By addition or by subtraction? Subtraction. That means one of them has to be positive, one of them has to be negative. So the middle sign goes to the bigger one. Which one is bigger, 6 or 35? So 35 has to be positive. Because this is positive. So 6 has to have what sign? Plus or minus? Definitely minus. Minus. So positive 35p, negative 6p gives us 29p. We are happy. And now we have to observe the sign. We have 35 and multiplying 7 and 5. By default, these are always positive because this is positive. So from here, which one is positive, which one is negative? 7 and 5 gives us positive. So 5 is to what side? 7 is positive, right? And you want the result to be positive. So 5 has to have what sign? Plus or minus? Positive. So positive times positive gives you positive. How about 3? 6 has to be negative. So 2 times 3 is negative 6. What sign 3 has to have? Negative. So 3 has to be negative, 5 has to be positive. So step 1, split them into 2 pieces based on the multiple choices. Step 2, play with the pairs. Take one from the left, one from the right, and see which pairs gives you the middle term. And then the third step, decide the sign for the constant only. By default, the first pair is always positive. And now the last pair, the last step. You write them into 2 binomial pair. In one pair, you write 2p, in the other one, 7p. So 2p times 7p gives you 14p squared. We are happy. Now, 15 is negative 3 and 5. But when you place them, you're going to place the other way around. Here you multiply 2 with the 3. So if you want to multiply 2 with the 3, it has to be on this box. If they're on the same box, you cannot multiply 2 with the 3. Right? When you do FOIL, you take one from the left, one from the right. So if you have to multiply 2 with the 3, 3 has to be here. So negative 3 goes to the 7 and positive 5 comes to the 2. So you rewrite them in other order. Here you multiply 2 with the negative 3, so you cannot have them in the same box. They have to be in 2 different houses. If you want to FOIL them out, and that's all you have to do. And this method is useful only for bigger numbers. And if you have multiple choices. If you don't have multiple choices, that means you have 4 guests to work with, so it takes time. Confused? Let's do one more together and then I'm going to give you your exam back. And in the exam, I'm going to ask this with this method. To try it for 1 minute. And then we're going to do it together. So which pair we are going to work with for 12? 1, 12, 3, 4, or 2, 6? 2, 6, because we have 2 and 6, both of them. How about 15? 1, 15 or 3, 5? Definitely 3, 5. Now let's see what do we have if you do this. 3 times 6? 18. 2 times 5? 10. When you combine, do you get negative 28x? 10 and 18 gives you 28, right? So combination does gives 28. We just have to play with the sign. 28 is negative, so which one has to be negative? 18 or 10? Definitely 18. The bigger one has to carry the middle sign always. Now if 18 is negative and you want the result to be negative 28, what sign 10 has to have? Negative. So we got 18 from 6 and 3. 6 definitely is positive. So what sign 3 has? The 18 is from 6 and 3, right? 6 is positive. By default, they both are positive. So if 6 is positive, but the product is negative, what sign 3 has? Negative, right? 6 times negative 3 is negative 18. We want to have negative 18. Now 2 times 5 gives you negative 10. 2 cannot be negative. So what sign 5 has to have? Definitely negative. So 2 times negative 5 going to give you negative 10. So we have our numbers and signs. We like 2x and 6x. And then what goes with 2x? Here, 2x multiplied with negative 5. So can you put negative 5 next to the 2x? No. So 5 has to be on the other box. That means 3 has to come here. Under question.
What if we switch those? Then 2x minus 5, 6x minus 3.
Then multiply and see, do you get the same thing? You cannot, right? Here he says you definitely have to multiply 2 with the 5. So if you have to multiply 2 with the 5, they have to be in 2 different boxes, not in the same box. The square says 2 this and that, then multiply this and that. So you can always check your work by multiplying them back. Any question? Martin? Okay, so 6x minus 5 here. And this one is 7p minus 3. So in the exam, I'm going to give you one of these. And definitely need to use trial. You cannot do this without it. Fill out, before you leave, fill out the thinking, reflection. At Jannah. Brandon and Dr. Rachel. Okay. So, Jannah. So, don't we please fill out the reflection attached. It's inside. Mario. Mario. Matthias. No. 13.
Oh, this is small.
Reflection is 2 points. You fill out the reflection. This summary reflection is 2 points.
Reflection. Yeah.
Reflection inside.
Oh, this is flavoring here.
No, you have to do same thing like this. So first you have to take the square root actually because cube will make it bigger. So it is square root of 81.
Oh.
9 and then 9 cube.
Oh.